Good morning, everyone. Thank you all for coming. I'm so excited to be here. St. Petersburg is a beautiful city. I'm from San Francisco. My name is Imad Elyafi, and I'm software engineer on web core experience team at Pinterest. I started using React 4 years ago when I was in Facebook, and one of the projects that I've been working on last year is React migration. Today, I'm going to tell you our story of journey to React. We're going to look into challenges we faced and techniques we used while migrating Pinterest profiles to React. If you have any questions, please make a note and I'll be happy to answer them in the end. And today's presentation is broken into 4 major parts. And the first one, why we actually had to migrate to React from the existing framework and why we've chosen React at all and not any other frameworks. The second part is about preparation of our infrastructure, basically what we had to do first before we could build something in React. The third part is about A/B testing and UI experiments, and this one is the most exciting part for me. And I'll be talking about how we measure impact, how we're making sure that our newly created UI performs better than the old one. And the last part will be about how our life has changed after adoption of React. So, why React? And our existing framework named Denzel was built at Pinterest and was introduced in 2013. It was a good framework that served us right until a certain period of time, but nowadays it's outdated. It uses object-oriented JavaScript approach and component-based hierarchy, basically things that are very common to many other frameworks that been introduced around like 3, 4, 5 years ago, and you may find something similar in your project. It's probably one of the most important questions why we decided to migrate to React and not Angular, Ember, or Knockout, or Meteor, or any other frameworks. And all modern frameworks are fantastic compared to what we had 5 years ago. Building single-page web applications nowadays is much easier. And we had 5 requirements to our new framework, and they're listed on this slide. You can see the very first requirement was having a large developer community. And React has a huge developer community, and we're excited to be a part of this developer community. Another requirement was design patterns, and React uses design patterns that are very compatible with our old stack, which makes the migration much easier. The third requirement was a solution for isomorphism, and I'll be talking about this a little bit more later and why this is important for us and why we had to do JavaScript rendering on the server side. The fourth requirement is performance, and we did a bunch of tests. We did benchmarking, and you probably all know about Virtual DOM, which helps to avoid a lot of performance bottlenecks and lets you move quickly. And the last requirement is developer experience, and our developer experience has changed a lot after adoption of React. You can see our old stack, and it's a Python Django web server, Jinja rendering engine on the server side, and Nunjax templates on the client. And it's pretty common. You may have something similar in your projects, but being on board with all of these, having Module Bundler, Redux, and many other tools and frameworks is life-changing, and our development of web apps has changed a lot after adopting all of these. Just to give you an example of scale, at Pinterest, we have 175 million of monthly active users. It's more than population of the largest country in the world, Russia. We also serve 150,000 requests per second. This is just to give you an example of scale that we operate at. And since we have so many users, we constantly ship new changes, run hundreds of experiments, and we can't simply stop development process in order to rebuild our web app from scratch. And while it's relatively easy to build new web app in React from scratch, migrating a service that is constantly changing and under development process is a much more complicated challenge. It's like changing engines of an airplane while you're in mid-flight. How many of you have tried to rewrite a web app from scratch? A lot of people. That's good. I had this experience before, and it was a nightmare. I ended up having 2 web apps that I had to support simultaneously. The old one, which is still in production, and product engineers making changes, shipping code, running experiments, and the new one, which is still under development process, where we have to port all these changes, and the new web app constantly chasing the old one. It's not a very pleasant situation. So how can we avoid this? And the only way to avoid this is to rewrite our web app piece by piece, while the rest is still run by the old framework. Thus, we will not have to implement features in 2 places, and we will not have to stop development process. So we're coming to this idea of so-called hybrid app. It's an app where we have 2 frameworks, and they coexist together for a certain period of time, and this period of time is time of migration to the new framework, React. And now we're coming to the question, how can we make a hybrid app? And the very first thought might be, it's not that complicated, but let's take a look at the list of the all possible challenges. First of all, React is a JavaScript framework. How many of you have JavaScript on the server-side rendering? Only a few people. So it's still not a very common thing, and there are many other different languages on the server side. We used to use Python. Some of you may use PHP, or you may have Java or something else. And having JavaScript in all these languages is not a very common thing. So as a very first step, we have to prepare our infrastructure first. And some of you may ask a really good question. Why do we actually need isomorphic rendering on the server side and on the client side? And there are 2 reasons for that. The very first reason is our engineers didn't have to do their work twice. They basically can create one template, and it will work on the client side and on the server side. Makes life much easier, right? And the other reason is SEO. And even though nowadays search engines, they can run JavaScript, it's still better to serve the initial markup as an HTML. So for SEO purposes, we really have to have isomorphic rendering and send everything, the very first HTML from the server. The second challenge is to render React components inside of your old framework. So once you can render JavaScript on the server side, now you want to build your new React components, and you want to make sure that they work in the existing framework. And while React is pretty flexible in terms of rendering, there might be some challenges. For example, what if your templates stored in separate files? Or what if your template engine uses a custom-made template language? And such example is Jinja templates in Python and Nunjax in JavaScript. The third challenge is to dealing with your old resources. And more likely you have a library which is built on top of AJAX requests, which does all the communication with the API for you. And more likely you want to reuse it at least for the first time. So you want to make sure that your newly created React components work well with the old API layer, so we can move forward quickly. And the last challenge is measuring the impact. How can we make sure that newly created React components actually performs better than the old one? And what if engagement is dropped? Maybe we introduced a bug, or maybe there is performance issues. How can we measure everything? How can we make sure that there is no drop and everything works fine? So here we outlined our 4 main challenges, and now let's dive deeper into each of those. And before, let me give you a very high-level view of our web app. There is nothing crazy. We have Python Django web server, backend API, and user agent with a bunch of assets, JavaScript, CSS, and images. As usually, user agent sends a request to the web server. It sends back a response, which is HTML, which is rendered using Jinja render engine. And after parsing this HTML, our browser spawns a bunch of requests to CDN. So basically, we're downloading all the assets, JavaScript, CSS, and images, and we're starting our web app initialization. After that, all subsequent requests from the client side are happening only to retrieve the additional data from the API. So we don't render anything on the server side. All subsequent pages are rendered on the client side, and all the requests are only sent to retrieve the additional data from the API. Now let me give you a little bit of a context about Jinja rendering engine in Python and Nunjax in JavaScript. These two template languages are very similar, almost identical, and because of that we had so-called isomorphic rendering. And the only caveat for that was that we had two sets of utils and libraries, and whenever someone added another util library, you had to port it into second place. Not the best approach, obviously. And let me give you a little bit of an example of Nunjax syntax. Is anyone familiar with Nunjax at all? Very few people. It's pretty regular templating language. Here you can see we're setting up 3 variables. We're reading properties from the data object, and we're reading greeting, name, and pins. And if greeting is empty, we will fall back to the default value, which is hello. And if name is empty, we'll fall back to guest. Pretty simple. Now you can see 2 curly brackets. Here we're actually executing our template. And if greeting and name is empty, we'll render hello guest, welcome to Pinterest. And finally on this slide you can see there is a module call. We're calling child module home feed, and we're passing all the options down to this function call. It's worth to mention that module is the function call. Basically, this template will be evaluated to JavaScript function call, and it will look up for this home feed module, and we will find it and render it. Does it sound familiar for you at all? React people? Yes? So it seems to be very similar to what happens in React, right? We're reading properties, we're passing them down, we're calling home feed module. Home feed is another function call as well, and passing down properties. It seems like these two architectures, they fit very well together. But the only issue, how can we render React inside of Python, which is a JavaScript library? And since JavaScript in Python is not a very regular thing, as a very first step, we introduced a Node.js sidecar, a standalone service which is used only for rendering Nunjax templates on the server side. So that will unblock JavaScript rendering on the server side, and our engineers will not have to migrate everything at once. They can migrate our service incrementally, module by module, step by step. That's why this is a very important step. And as a bonus, there is no more duplicating utils and libraries. We can use the same ones on the client and on the server side. So now, on this slide, you can see our migration path to React. We're basically migrating from Jinja in Python, Nunjax on the client, to Nunjax on the client and on the server as a very first step. Now let's take a look how Jinja rendering used to work before introducing Node.js sidecar. And you can see the architecture, and as it was before, user agent sends initial requests, and our Python Django web server starts rendering process. But before it requests the initial data from the API for our template. At this point, our template is being rendered serially. So basically, we render module by module, and it renders as far as it can go until additional data is needed. And at this point, we're requesting the additional data from the API. Worth to mention that this process is CPU blocking and nothing else can be done. Basically, we render our template serially and blocks the whole thread. Now, since we retrieve the additional data, we continue our rendering process serially as far as we can go. And at some point, we need additional data again, and this process repeats. It repeats until we render the whole tree, and at this point, we render the fully rendered HTML to the user agent. Now, let's take a look what happens after we introduce Node.js sidecar. Now you can see that the overall architecture is very similar, but now we have a layer of NGX proxy, which is used for load balancing and Node.js workers. As it was before, user agent sends a request to Python Django web server. And again, we retrieve the initial data from the API. And here where it becomes different. We send a request to our Node.js sidecar in order to render our template. And it goes to one of the node workers. And it renders template as far as it can go until additional data is needed. At this point, we send back the partially rendered template to our Python Django web server. We retrieve additional data. And now we're sending multiple requests, each per each subtree, unrendered subtree, in order to continue rendering process. So now the process of rendering our templates is no more CPU blocking. We can render subtrees in parallel. This was one of the important optimizations which helped us to save a lot of CPU time. So after rendering these subtrees, we're sending back partially rendered template to the Python Django web server, and we continue the process. Again, we're retrieving additional data, and the process repeats until the whole template is fully rendered. And in the end, we're sending back the fully rendered HTML. How are we doing? So far, so good? Cool. So now we have pure isomorphic rendering on the server side, non-JAX in Node and on the client. And now we can start actually building things in React. And as I mentioned before, we used to have our old framework named Denzel. And this is a framework which uses object-oriented JavaScript approach, and it has component-based hierarchy. On this slide, you can see an example of our Denzel module call inside of non-JAX and React component call inside of non-JAX. And as I mentioned before, module is a function call. The same applies to a component word. So basic component is another function call which will fall back to React rendering. And in order to empower our engineers to migrate our service incrementally, we added a React-specific bindings to non-JAX rendering engine with the new keyword component, which represents a bridge between Denzel and React. And on this slide, you can see a very simplified version of Denzel React bridge. Basically, it's a Denzel module which is used for rendering React components. Let's take a look how it works. So basically, whenever our non-JAX renderer meets component keyword, it will render this module instead. And the module, in its turn, once it's added to the DOM, it will render, it will check the name of the React component and will read all the options. And as a next step, it will render React component in its own container element and will pass all the options as a properties. So this is pretty simple approach, but pretty powerful technique. You can use such approach from pretty much any other library or templating language in order to render React components inside of your framework, the existing framework. And some of you may ask a question. If we render HTML on the server side and then we send it to the browser, how actually React will reuse this HTML? And this is one of the cool features of React. Basically, when it renders HTML, renders component on the server side to a string, it will add a checksum to it. And once the web app is initialized, React will re-render its own component into virtual DOM, not real DOM, but virtual DOM. And this rendering process is very fast. It will render it in virtual DOM and add another checksum. If the checksum is the same, that means that React can reuse the existing markup, and there is no need to replace the existing DOM components. This is super efficient, and it helps to avoid such things as UI flickering, because if you even replace the same DOM elements with the new ones, it will actually flick and you'll have like blinks on your screen. You don't want to have it. So this is one of the cool features of React. Now, let's take a look in our third challenge and how we will deal with the old resources. As I mentioned before, more likely you have a library which is built on top of Ajax request, and you more likely want to reuse it at least for the first time of your migration. And for that purpose, we used harder components, or basically HOCs. HOC is a powerful technique which lets you to reuse components logic. HOC is a function which takes a component and returns another component. I know it may sound a little bit confusing, but let's take a look at the example, and I think everything will be more clear. On this slide, you can see a version of with resource HOC on the left side and an example of usage on the right side. And we used HOCs in many places, but the main one was data supply and dealing with the old API layer. Now, let's take a look how it works. On component did my own lifecycle event, it will create a resource and will send a request to the API. Once the data comes back, it will change its own state, and it will trigger a rendering of its own component. After triggering rendering, it will replace the previous property, data property, with a new one, and will keep in sync your newly created React component. So basically, it's pretty simple technique, but pretty powerful, and you can use it in many places for keep in sync with your API layer and reusing your old API library. So now, at this point, we have Nunjucks on the client and the server. We can create React components inside of Nunjucks, and now we can move to our fourth challenge, measuring the impact. And this is one of the most exciting part for me. I love A/B testing and experimenting. So with more than 175 million of users, we want to roll out things carefully. We want to make sure that newly created UI is actually performing better than the old one. And for that purpose, we're using in-house built Gatekeeper framework. And how many of you have used A/B testing frameworks or something like that before? Quite a lot. That's good. If you have something similar in your project, this is a very handy tool in migrations like that. And A/B testing frameworks, they used to check if your newly created UI performs better, or if your changes actually work well. You can do it kind of like testing. On this slide, you can see a very simplified version of a code snippet where we check if user passes an experiment check, then we render a newly created React component. Otherwise, we fall back to the old Denzel module. Now, let's take a look deeper into the experiment setup. You can see on this slide our old module tree, and at some point, we decided to fork our logic based on experiment check. We want to render control version, which is old Denzel components, or we want to render enabled version if user passes the experiment setup. It's worth to mention that once we converted Node to React call, all its children and descendants are necessarily in React. This is very important. It means there is call of React inside of Denzel, but there is no call of Denzel inside of React. So once we go to React, we don't go back. And it helps to make the migration much cleaner and smoother and well thought. Otherwise, can you imagine what will happen if you render React inside of Denzel, then Denzel inside of React, then we'll go back and forth? It will be a total mess. You don't want to do this, right? So because of that, we call it bottom-up approach. Basically, you have to start from the very leaves and you migrate to the very top. As I mentioned before, it makes everything much cleaner and well thought. Also, it's worth to mention that you probably want to run experiments at maximum per page level, or sometimes per large components. And you definitely don't want to run experiments like comparing your old web app to the new one, because your metrics and numbers will not make sense at all. you have so many factors that moving your metrics that you will never investigate them. Also, you really want to run your experiments exclusively. Otherwise, if user is exposed to 2 experiments that may affect each other, then your metrics will be off again. You don't want to do this. So you want to run experiments exclusively. Later on, we can log into our experiment dashboard, and we can see different metrics. For example, pinner wait time, user engagement metrics, performance metrics, and many others. If you see a drop in user engagement, then probably you introduce a bug, or performance is so bad that people basically giving up, So it's a good signal to investigate. On this dashboard, you can see we have a lot of squares on the right side in names of the metrics on the left side. Blue ones means everything is good. We have improvement in our metric. Red one means there is a drop and we have to investigate. The gray one means there is not enough of data to make sure that metric is statistically significant, or basically it's neutral. So running experiments in migrations like that is actually very critical. Even if you have things like integration testing, auto testing, manual testing, and so on and so forth, unlikely you'll catch all the bugs or issues. For example, what if something goes wrong in countries with poor internet connection? Or what if something goes wrong in different languages? Or another example could be, what if transition from one page to another one is very slow? Unlikely you can catch this with auto test or integration test. And this will actually affect user engagement a lot and will drop key company metrics. That's why using A/B testing frameworks and things like that is very handy in migrations like that. So now, Pinterest profiles were the very first user-heavy page that was successfully converted to React. And while converting Pinterest profiles to React, we've seen consistent performance and engagement improvements. For example, such metrics as DOM interactive, response end, and board page views were improved up to 20%. And this number 20% is just from changing gears and infrastructure without making any UI changes, without any redesign. I think it's a pretty cool result. And while we were converting Pinterest profiles to React, our product engineers were able to continue to build features, making experiments, and continue the development process. And finally, all of these leads to a completely new developer experience. After adoption of React, we don't have any duplicating Nunjax and Jinja libraries. There is no need to learn Nunjax at all. It makes onboarding process much easier. So all our new engineers, they don't have to learn these libraries and tools. They can just simply start. And having single language on the client side and on the server side makes life even more easier. And being on board with large developer community, it's super helpful because there is no more wiki pages. We basically can go online and read all the documentation. There is no need to maintain all these wiki pages and all the information. So it's been a long journey, but we're excited to be part of huge React community. Thank you, guys. Any questions? No questions?
Hello, thanks for talk. Can you talk about a bit better, a bit more, how do you call Node.js from Python or from Django framework?
Yeah. So the question was, how do we call Node.js from Python?
And the second question will be, is it developer experience and development setup is harder now because you have Django, template and edit, and you render response, but now you need to set up all the servers.
Yeah. It's a good question. So Node.js is a standalone service. It's a process within the same server. Basically, we do a network request per each template rendering. And it does add a little bit of overhead, but with all other optimizations, it's actually balance out everything together. So that's how it works. It's a network request, which is sending a network request. And the second question was about developer experience and about setting up your environment. And it actually, for developers, it didn't change at all, because you have the regular build process where you have Webpack and everything else, and there is a lot of other things combined in together. And basically, people who are in charge of build process, they're taking care of it, and it works well together. There is one more.
Thanks for your talk. Do you have a DevOps team to maintain all this infrastructure?
Infrastructure?
Yeah, DevOps.
Yeah. So the question is if we have a DevOps team.
Yeah.
It's a really good question, because once you introduce new services, and more likely you're the owner of these services, and in our company we set up on-call, and our team is in charge of everything that will happen. So we have on-call rotation. We are a pretty big team, 15 people, so it's not that bad, but unlikely you'll be pinging late at night, but during release or something, things may happen and you have to investigate. But we also do have SREs who are in charge of infrastructure on the very, very back end. But once you introduce a service like that, you actually have to maintain on-call rotation, or someone else at least.
Thank you for sharing your experience. I have two questions. First of all, in your story, that step when you moved to Node.js seems very, very expensive, very painful. Was it really so? Is it comparable? I mean, the other steps that you made seem to be like, well, much more simpler. So was it really so tough, that tough step? And the second question is about, well, the future of your infrastructure. I guess you mentioned your plans for future in the contents, but you didn't say what are the next steps. Will you get rid of this templating languages? What will stay?
Yeah, that's a good question. So the very first question was how hard to introduce. Yeah. I mean, there is a lot of work, obviously, to do things like that, but it's a very flexible approach. You don't want to do some crazy stuff like, maybe you can render somehow JavaScript and Python, but this approach is very flexible. No matter what you use on your server side, even though if you use PHP or Java, basically pretty much any project, you can do things like that. And having like microservices like that is actually one of the best approaches and recommended pattern. So it works very well, and I don't think there is like some rocket science, like crazy things may happen. And so what was the second question? Oh yeah, so this is a very first step. Basically, our product engineers, they migrated to React, and they left at the very top level component as a Denzel framework. And it was used for supplying data for the initial template. Do you remember when we send requests, we supply initial data? But actually, the second step, carving out Denzel, is super simple, because you have only top level components, and they are existing only in one per page. So it's basically very easy for you to carve it out, and you can start using only React. And we call this process pure React. And the last step, which is right now is finishing at Pinterest, we're actually swapping these two servers. We're going to hit everything from starting from Node.js, and then if we have some old templates, not on Pinterest.com, but on any other internal tools or services which are not that critical, we can always fall back to Python again. Yeah, and this part called 100% Node, and it's almost done.
And also, it would be interesting to know, where do you get all these readouts about UX experience, user experience, I mean, feedback? Was it worth to change to React or something like that?
Just change to React without running experiments, or?
Yeah, about A and B tests.
Yeah, so
But where did you get it, this information? I mean, minus, plus, 1.
Oh, okay. So we have an experimenting framework called Gatekeeper, as I mentioned before. So how it works, whenever you fork your logic based on experiment condition, we bucket each user into certain experiments. So basically, once you're exposed with React, we say, okay, this user is in React, and we render everything in React. Then whenever you do some actions like pinning something, or loading a page, we're sending some information like performance data, number of actions, and stuff like that. And later on, all this information is accumulated on the back end, and we have data job, which runs and calculates everything and says, okay, this user is an experiment of React, and it performs that well, right? Another user performs like not as good when he is in Denzel. And once we have a lot of users, we can actually run and calculate this data and get all the information statistically significant. So it's basically more or less scientific approach. Whenever you want to make sure that something works well, you take a group of people, larger better, and you just calculate statistics. Another question.
Yeah, one more question. Could you tell us more about the future, about what you're planning to do with the React store? You mentioned that you use this adapter approach to integrate with your old getting data from the server. Mm-hmm. And are you planning to use something like Redux or Modex?
Yeah, that's a good question. So are we planning to use Redux? And we actually do use Redux already. And this part, which is called Pure React, when you're removing Denzel, we'll hydrate store on the client side, Redux store, and we'll use so basically once you convert everything to React, there is you can do whatever you want, right? And even though before we started removing the top-level Denzel components, we already started using Redux and other stuff, so it's not blocking you. But basically, the whole idea behind this migration path is you want to narrow down your problem, and you want to reduce number of variables, because quite often people want to migrate everything at once, and they're ending up with a project which is runs several years, and because your old web app is still under development process, right? You cannot stop it. You have to create new features and so on and so forth. So this approach, you're narrowing down your problem to the minimal set, and you can iterate on it quickly. And once you reach this milestone, you can move forward and go to another milestone.
Hello, my question is about future as well, but from the other angle. What bottlenecks do you see in your current setup, and what future improvements your team is going to implement?
Yes, so the question was what bottlenecks I do see in the existing setup and what future improvements we'll be doing. And starting with future improvements, since Denzel was for about 5 years, it was highly optimized, and React performance was, in the very beginning, was server rendering a little bit better, but we didn't spend another 5 years on optimizing it. So there is a huge room for improvement. And a lot of things that can be done, like retrieving data from the API faster, like basically reading data from the API faster. There is a lot of things we can do, and community actively working on that. So, and talking about bottlenecks, one of the probably things that slows down rendering a little bit is that you have to send a network request to your sidecar. Even though it's a process on the same server, it adds a little bit of overhead, like maybe 10, 15, up to 20 milliseconds. So it's not that critical. Other than that, I don't see any other bottlenecks. One more.
And how do you actually pass the data and session cookies? How do you pass session cookies or data to the Node.js? Do you pass data in post?
So you send a post request and you send the whole information within the context. You want to render, because we just render templates on Node.js, right? We don't do any other things. And with all that said, you really want to send all the context and environment variables within this request. And also, because of how Node.js works, you don't want to use global variables or singletons, right? Because when your callback function waits for when something will be done, you pretty much you can have name collision. If there is another request goes to Node service, right? Then it will start rendering with the old singletons and old context environment. So that's one of the things you have to take care of.
Hi, thanks. That was good. I unfortunately missed the very first part of your speech. When did you decide to move to React?
So the decision was made quite a bit long time ago, and there was a lot of communication about that. There was staffing, basically hiring the right people to do this whole process. And I would say React migration has started like a little bit more than 1 year ago, but the whole process was built in such a way that product engineers, they started migrating products only in January, in the end of January of this year. And they migrated pretty much everything in like a few months.
Yeah, okay. And I wanted to ask, you told about the common pros of React? Yeah?
What, sorry?
The pros.
Oh yeah, pros and concerns.
5 advantages. Mm-hmm. And when you decided to, when you chose the React, were there any suggestions about Angular, maybe because there was Angular 2 already, yeah?
So when we were considering using React, I think when we were creating all these Go docs, but people didn't actually start migration process. It was just a lot of preparations and discussions. At this point, Angular, I think there was already obvious Angular 2, but there was no clear migration path from Angular 1.5 to 2, and 2 wasn't that stable. And also, even though if Angular 2 probably would be not a bad option, but React community is evolving a lot, and there is a lot of this momentum, a lot of people in it, and this aha moment is actually very important, and you really want to be on this wave with everyone else.
Okay, thanks.
You're welcome.
Hi, thank you for the talk. Great talk.
Thanks.
So you were talking that you were saying that fetching data on the backend is a bottleneck in some cases.
No, I didn't say this.
No, when we were discussing, you were asked what you think was the bottlenecks. Mm-hmm. So when you're rendering content on the backend, you're fetching data from some other services, and this is a bottleneck for you, or?
No, the bottleneck was that you actually, whenever you want to render a template, you have to send a request to another service, and it's a network request. So you want to make sure that this network request is actually very fast. Otherwise, if it takes 100 milliseconds, then
it might be a bottleneck.
Yeah, it might be. It's not a bottleneck. I mean, that's one of the things that you have to consider before moving to architecture like that.
Okay, great. Thank you.